Hello everyone and welcome. In this video we will look at a coding interview called Find K Closest Elements. In this problem you have to implement a function called Find Closest Elements accepting three parameters. A list of numbers called array over here. Our input array is sorted in ascending order starting from the smallest one first. An input parameter k and an input parameter x. Both of these are numbers. You can try out this problem on LeetCode. You can see it over here, you can see the description, and you can try different solutions. What I'm going to do here to explain the problem is explain it by showing you different examples and the solutions. So over here I have a number of these examples. For example, the first one, k equals 3 and x equals 8. We need to find three numbers in our input list, because we have k equals 3, that are closest to the number 8. So in our input list, 8 over here has a distance of 0 to x, because x is 8. 9 has a distance of 1, right? 9 minus 8 is equal to 1. And 7 also has a distance of 1, because 8 minus 7 gives us 1. 10 has a distance of 2. 5 has a distance of 3, right? 8 minus 5 is 3. And 13 has a distance of 5. So in this particular example, the three closest numbers to 8 are the 7, the 8, and the 9. We would have to return the sublist of 7, 8, and 9. The other constraint is that we have to return the output in ascending order, sorted smallest one first. Let's look at the next example with x equals 8 and k equals 4. This time it's the same problem, but we have to choose 4. So again, if we work out the distances, we have the same distances as before. We have the 0, we have the 1, 1 again, 2, and 3. And out of these, we choose the 4 elements that are closest to x, that have the smallest distance. The result would be 7, 8, 9, and 10. Let's now look at another example. Again, x equals 8 and k equals 3. Let's work out the distances. We have 0, we have 1, we have 2, all right, 10 minus 8 equals 2. Then we have 3 over here, and as you can see, we already have the solution. We just need to pick the three numbers that have the smallest distance. So these are the 8, 9, and 10, and of course we have to return them in ascending order. Another example, x equals 5, and this time 5 is not in our input list of sorted numbers, and logically 5 is somewhere between 3 and 6. The distance of 3 to 5 is 2. The distance of 6 is 1. From 5, we are just doing 6 minus 5. To 9 is 4. And to 2 is 3. And since k is 3, we are just going to pick the three numbers with the lowest distance. In this case, we pick the 2, the 3, and the 6. One more example, this time x equals 9. The distance to 9 is 0. The distance to 8 is 1. 1 again. The distance to 6 is 3. The distance to 3 is 6. The distance to 2 is 7. And we have k equals 5. So we just need to choose 5 numbers from here. And we choose the numbers 3, 6, 8, 8, and 9. One final example with x equals 20. Again, 20 is not even in our input list. However, 9 has a distance of 11 to 20. 8 has a distance of 12. 12 again, and 14. And since we have k equals 3, we just need to choose the last three numbers, the 8, 8, and 9. So now you have kind of understood the problem by working through some examples. If you want to work out on the solution yourself, try to pause the video over here. I suggest that even if you come up with the solution, you still come back and see the solution that I implement, because the solution might be different. Also, while you're thinking about how to solve this problem, please think about subscribing to this channel. Let's clear everything from here and stick with just one example for now. Let's just comment these other examples over here. We'll just comment all these lines. And let's start by breaking the problem down and look at the tools that we need to solve this problem. The first thing that we need is to find how we can calculate the distance between a number and x, our target number. We can use subtraction for this, right? So if I go to my main function over here and I do print 13 minus x, 13 being the last element in our example list. And let's put another example. Let's do 5 minus x, which is the first entry in our list. And if I run this, the first result is 5, so 13 minus 8 equals 5. This is the distance to x. And the second result is minus 3, because 5 minus 8 is minus 3. The correct distance would be 3, so we need a way to convert this into a positive number. And we can use the absolute function for this. Okay, we just wrap it into the absolute function from Python. And what this function will do is that anything that is negative, it will turn it into positive. So now when we run this again, it will give us 3 and 5. Over here I have written the example that we have, the first example, and we are going to try to solve it with our input of k equals 3 and x equals 8. One way of solving it is to find x in our input, in this case it's over here, and then start with the adjacent number. So you assign a pointer to each on the 7 and the 9, calculate the distance to each, and then move these pointers to the right and to the left, every time finding a new nearest element. And we keep on doing this until we have enough numbers, until in this example we have k equals 3, until we have 3 numbers. There are a few problems with this approach. The first problem is, how do we find the number 8 in our input? We could use something like a linear search. We go checking the 5, the 7, and then the 8. We stop at 8. Or we could use also something like binary search to make it faster. However, it gets a little bit complicated when we don't have the number in our list. When, for example, over here we have x equals 5, we wouldn't be able to find 5 in our input. The 5 would be somewhere between the 3 and the 6. The other complication is, how do we move the two adjacent pointers? And also we need to move the pointers in a way so we collect the results in an ordered fashion, starting from the smallest one first. So you can understand there's a lot of moving pieces in order to solve it in this manner. There's a lot of small problems to solve. And usually when you come up with a solution that feels like it's too complicated, like there is a lot of small problems to solve, it's likely that there is a neater, simpler algorithm. So let's have a look at again our example solution, the 7, 8, and 9. And as you can notice, these are consecutive numbers in our input list. The output is always a sublist within our input. For the second example, we have the 7, 8, 9, and 10. It is a consecutive list. We never get a situation, for example, where we have, let's pick this one, where we have the 5 and the 8 and then the 13 on its own joined together. It is always a continuous sublist. In this example would be the 8, 9, and 10. So really the problem here becomes of finding the sublist, this window in our input list with k elements. K being the size of this list. For example, here we have k equals 3, here we have k equals 4, again k equals 3, and so on. So we can simply try to think of a solution by moving this window along of a fixed size. So let's experiment a bit. Let's say we create a window of size 3, because we have k equals 3 starting from the first element in our input. And with this window, we need to decide whether it contains the elements that are the closest to x, x being 8. And let's assume for now that we have a way to determine how close the elements of this window are to x. What we would then do is simply move this window one position forward, both the front and the end, and again do this calculation to figure out how close this window is to the letter x. And we continue in this fashion. We move it one forward, again we calculate how close all the elements are to the input x, and after that again we move the window one position forward and do the same calculation again. Once we reach the end of this list, we simply pick the window that has the smallest value, that is closest to x, and then we just return it. We don't need to sort it because the input list is already sorted. We just need to return it as it is. In order to help us find which window is the closest to our input element x, in the first example x equals 8, we can create a new list of the same size of our input and calculate the distances for each element. And we can calculate the distance from each element to x, x equals 8 in this example. So for 5, the distance is 3. For 7, the distance is 1. We are just doing 8 minus 7 over here. For 8, it is 0. For 9, it's 1. For 10 equals 2. Okay, 10 minus 8. And for 13, it is 5. So now let's go to the code and implement this part where we're finding the distances of each element. And to do that, we can use the absolute function. And we say n minus x, n being each element in our input list, which is the variable called array. And we can use a lambda function for this. We can say lambda accepting n, and we wrap all of this into the map function. What this is going to do is simply iterate over our input list, the list with the variable called array, and for each element we are going to subtract it by x and find the absolute. And the result, we can put it in a list ourselves. This way we have a list of all the absolute differences. And we can call this list absolute list. And let's try it out. Let's simply print it just to check that it is working. And if we run it, as you can see, it gives us the correct solution, the same that we have worked out together. Let's now try to use the window technique that we discussed before on the list of differences instead of the original list. So if we start a window of size k from the first position between 3 and 0, and remember, all we need to do to model this window is to just keep a pointer to the first item of this window, because we know the size of the window, because it is always constant, the size of this window, in fact it is of size k. So we just need the variable I to point to the first position, and then we keep moving I forward as we are doing our calculations. And what we can try to do is to sum up all the absolute differences inside this window, which in this example it will give us 4. The reasoning here is that when the sum of the differences inside the window is at a minimum, all the elements in that window are the closest elements to our input x. So then what we do is to move this window forward. By moving it forward, we just need to do I plus 1. In fact, we can move I 1 position to the right, and we just need to compute again the sum. And in this case, the sum inside the window is 2. 1 plus 0 plus 1 is equal to 2. Let's again move the window 1 position to the right, again just by incrementing I, and the sum this time is 3. What we can do, instead of summing up the entire contents of the window every time we move the window, instead of summing every element up again, what we could do is use a small optimization trick. We are only moving the window 1 element to the right, so what we could do is simply add the element on the right. In this case it is 5, we just add it to the current sum, so we do 5 plus 3, that is equivalent to moving the window 1 position to the right, and then we subtract the element on the left of our window, which is equivalent to moving the start of our window 1 position to the right. So in this example we have 3, the previous sum, we add 5 to this, giving us 8, and we subtract 0, which has the result of 8. This way we don't need to sum every element in our window again every time we move the window. We just need to do 2 operations, subtract 1 and add another one. And now that we have all these absolute summations, we just need to pick the minimum one. The minimum one over here is the sum of 2, which is when we had our window on these 2 positions, which gives us the original numbers of 7, 8, and 9, the correct solution. Let's now move all of this to the right so we can write the solution in our code. And if we go to our code, let's remove this print statement and let's write this algorithm. Let's create a variable called absolute sum. This will simply represent the sum of all the values in our window. And initially the window will be at the first position when I is 0. Alright, we start with 3, 1, and 0 in this example. So in our code, we just need to sum the absolute list starting from position 0 up to position k. Remember that k is 3, and in Python, when you use this syntax to produce a sublist, the second argument is always exclusive. So we have a sublist starting from 0 and finishing at position 2. Next, we need to simulate this window moving forward, and we have mentioned that we just need to keep a variable I and we just need to move it to the right. And we can do this with a for loop. We say for I in range, and we start from position 1, which is the next position after our initial window. Remember that our initial position is 0, okay, when the window is at the start. And in order to help us, let's write the indexes of each element in this list. We have 0, we have 1, 2, 3, 4, and 5. So when we start from position 1, we have already moved the window to one position to the right, and we need to keep on moving this window until we arrive at the end. And the end is when our window moves all the way to the right, and I is at position 3 in this example. And we can arrive to this number 3 in this example by simply getting the length of our list. So we say length is equal to 6. This is the length of our input list. We subtract k from it, which is 3, and this will give us the last index that I needs to stop on. So over here, we just need to write length of array minus k. However, in Python, the range function is exclusive. We always stop 1 before. So we need to add 1 to stop at position 3. This is because the loop is exclusive. Now we need to do that calculation that we talked about when we move the window, the adding and the subtracting of the elements. So the first thing is to add the next element when we are moving forward. So in the code over here, we do absolute sum is equal to the current value of absolute sum, and we add to this the next value. This is absolute list at I plus k, and if we look here, for example, when I is at 3 and we add k to it, so 1, 2, 3, we end up 6. We end up out of bounds of our list. So we need to subtract 1 from here. And we also have to remember to subtract the previous item when we move the window. And let me make some more space over here by moving all of this to the right. And in our code, we just need to do minus abstract list at I minus 1, the previous item that we were at. So what we have done until now is find this sum of these absolute distances on every position of this window. We need a way to maintain which one is the minimum one. After all, this is our solution. So in our code, let's create a variable called minimum I. This will represent the pointer of where the window starts when the absolute sum is at a minimum. And let's also create another variable called absolute sum minimum, which will contain the value of the sum when it is the lowest. And inside the loop, we just need to maintain these two variables. And we say if absolute sum is less than the current absolute sum minimum, we need to update that value. We need to say absolute sum minimum is equal to absolute sum. And then we say minimum I is equal to I. At the end of this loop, minimum I will be pointing to the start of the window containing our solution. In this example, minimum I will be 1, and the absolute sum minimum will have a value of 2. We just need to return this window. So we say array starting at minimum I, this pointer over here, position number 1 in this example, up to the minimum I plus k. Remember that the size of our window is k. Let's tidy up and remove all of this, and let's now uncomment all of these lines, and let's run this program and see the answers. As you can see, each one of these answers is correct, giving us the correct solution. So this was the solution of the find closest k elements. If you like these kind of videos, let me know in the comments below, and please subscribe to support the channel.